This video is about AVL tree or self-balancing BST. So what does this BST do? BST means binary search tree. Binary search tree means a type of tree data structure in which the left child is less than or equal to the root node and root node is less than equals to the right child. So that is a BST or binary search tree. But what is a self-balancing binary search tree or AVL tree? See, suppose we have an example of nodes, like here it is 15, 14, 13, 12 and so on. So this type of tree is known as a skewed binary tree. Left skewed binary tree because all the elements are aligned to left hand side. So in general, the searching in a binary tree has a complexity of big O of height, because at max it needs to travel that much path or that much edge as it has its height from the root node till the leaf node. But for okay, if the binary tree was like this balanced, then for n nodes the height of the tree is log n base 2, because this is 2 to the power 0, 2 to the power 1, 2 to the power 2. So like that, log n base 2 is the height. But if it is skewed, then the height is same as n. Now tell me, log n base 2 is greater or n is greater for particular value of n? So n is greater. So when binary tree or binary search tree is skewed like this, instead of getting balanced like this, then we are getting more time complexity, or we are getting delayed in searching. So for such reasons, the scientist said that the tree should be balanced. So a tree that should be balanced or that can balance itself is called as a self-balancing tree. AVL are named upon the scientists that had made this BST. So an important factor or the main deciding criteria for self-balancing BST is the balance factor. Means for each node in the tree we need to calculate the balance factor. So how to calculate balance factor? It means height of the left subtree minus height of the right subtree. For this node, height of left subtree is only 1. For this node, height of right subtree is only 1. So 1 minus 1 is 0. Suppose here only one child is there, then here left it is 0, right it is 1. You can calculate height, or you can say number of edges that we have to go, like that. So here it is 0 and here it is 1, 0 minus 1 minus 1, here it was 0. All the leaf nodes will always have balance factor as 0 because it has no children, therefore no subtree. So how means 0 minus 0 is 0. Similarly for this, it is 1, 2. Either I can calculate like 1, 2 or 1, 2. It's the same thing. Generally I need to calculate the longest. And here it is 1, 2. So it is 2 minus 2, load factor is 0. Suppose here I have another child. Now here I am inserting the node here. Therefore, first of all, load factor of this means its direct parent, the node that I have inserted, its direct parent, its parent, its parent until the root. Only these nodes will be affected. The balance factor of others will remain the same. So here, since it is a leaf node, or we can say 0 minus 0, balance factor is 0. For this, it is 1 minus 0, therefore it is 1. Then for this node, it is 1 minus 1, 2, or it is minus 1. For this node, it is 1, 2, 3. Minus 1, 2. 3 minus 2 is 1. So here also it is balanced. Now suppose I was not having this part. Then for this node, it is 1, 2, 3 minus 1. Balance factor becomes 2. So we will say generally a balance factor for a AVL tree should be between 0, means should be between minus 1 to 1. The values it can have is 1, 0 or minus 1, but this node is having a balance factor of 2, which implies that this tree is now not balanced. We need to balance it. Depending on the imbalance, we will balance it.